A little bit of time now working on some questions. We have minimum swaps to make strings equal, number 1247. Just give it a moment here, make sure that everything's working. Minimum swaps to make strings equal. Okay, the audio's working. Very good. All right. So let's do this. Yeah. I haven't been on for a few days, a couple days. Just some things I was looking into. Okay. You're given two strings S1 and S2 of equal length and consisting of letters X and Y only. Your task is to make these two strings equal to each other. You can swap any two characters that belong to different strings, which means swap S1 of I and S2 of J. Return the minimum number of swaps required to make S1 and S2 equal, or return -1 if it is impossible to do so. Okay. XX, YY, swap to get YX, YX. Oh, that's interesting. So two strings of equal length consisting of letters X and Y only. Your task is to make these two strings equal to each other. Can swap any two characters that belong to different strings, which means swap S1 of I and S2 of J. Okay, return the minimum number of swaps required to make S1 and S2 equal, return -1 if it's impossible to do so. Okay, well, if you swap the same characters, they'll never be equal, right? If the characters are different from each other, and if they are already the same character, then there's no reason to swap them. So you're always going to be swapping characters across. Okay, maybe let's see. Pretty low submission rate, pretty high acceptance rates. Probably a lot of people skip this one. Probably you could do a dynamic programming solution for this. Yeah, you could do quadratic time. That would work. I'm thinking if there's a brute force solution that could be done here. Like a basic approach. So I think there might be a quadratic dynamic programming solution. Quadratic dynamic programming solution. That's my guess. First guess. X, Y, Y, X, 2. Swap 1 and 1 to get something like this. And then another swap. XY equals XY. Cannot swap S1, 0, S1, 1 to make S1 equal to YX because we can only swap characters in different strings. Okay. Yeah, I can't swap these two. They have to be different strings. Interesting. Okay, I don't have an immediate solution. I have to think about it. So this one's not possible. The first thing, in order to be able to have a solution, it's necessary that the frequency map is even. The frequency map of all the characters is even. In which case it's not. In this case, 3 X's and 1 Y. It's not possible to get what you want. Then actually you'd want, in order for the strings to be equal, you'd want basically one character of each of the frequency, well, half the characters of the total frequency be placed in the first string in a certain sequence and half the characters in the second string in another sequence. And the minimum number of swaps is what you need to achieve that, right? To move those characters into those positions. So here they went with YX, and YX is the optimal sequence. And then we move a Y here, and that moves an X over there, and then X is already in the right spot, and that X is also in the right spot, and Y is already in the right spot. how can I figure out what that optimal number of swaps is? Can I just get like a suboptimal number of swaps? Like, is that possible? Like, can I just do I could just do every character in sequence, right? From left to right. And that would be XY. So I could do XY here. X would already be in the right spot. Swap this X with a Y. And then actually those would also be in the right spots still. Okay. That only takes one swap. Excuse me. What if I want to move? Trying to think of a basic way I could do this. I should. Oh, here we go. Perfect. Oh no. Excalidraw, right? You can use Excalidraw. It's a good name. It's a good name. All right, I'm looking for something specific here. Let's do A's and B's, right? A, B, B. Okay. Let's say I want to have I have 1, 2, 3, 4, 5. 5 A's. Let's do 6 A's. 6 A's and 6 B's. So I can do 3 A's in the front and 3 B's. And this is the sequence I want. Well, I can swap here. 1, 2, and 3. And that's perfect. 3 swaps. And I think that's optimal too. Can I prove what like the smallest number of swaps needs to be? Well, your frequency map needs to be A3 and B3 times 2, more or less, right? Can you see that? Yeah, you can. And I have total frequency map is A6, B6, right? That's how I get that. Just divide this all by 2. But I have A6, B0, and I have A0, B6. Number 1, number 2, right? So that's some handwriting I got going on here. Okay. So the question is, like, what do in order to get 3, I've got to move 3 here, and I've got to move 3 there, right? And each swap constitutes moving 6. Like, each swap moves 2 characters at a time. So that's a total of 6 characters moved divided by 2 is 3. So the minimum number of swaps is going to be exactly, it's going to be this difference, right? It's going to be six minus t absolute value, or a, a sub, let's do alpha sub a minus t absolute value, where t sub a plus alpha sub b minus t sub b, where I'm bringing a down to the target and bringing this a up to that target. And necessarily these two added together give you the target. So you could always just use, so the amount that's going to move in either direction is going to be the same. So it's going to be these two numbers, same thing over here, 3 plus 3, and then this whole thing divided by 2. Just to say this is the sum of alpha sub, call it x, or alpha sub beta, where beta is an element of the character set. I don't know, CS versus character set. Element of cesium, half of that. Right, that's the minimum number of swaps, right? Something like that. And then like that, you need to do that many swaps, right? At least. Do you have to? Maybe you need to use more swaps. Is that the only number of swaps you can use? Can you always perform that many swaps? If you could always perform that many swaps, then this is very straightforward, right? I could just calculate this number straight out and be done. It'd be very easy to do that. If it's not always possible, well, it's not always possible if, for sure, if this, if the sum, each sum is not even, right? Every sum has to be even. In other words, each target has to be even. That's the first thing, or not the target, excuse me, just the sum. Alpha sub a plus, I don't know, alpha, yeah, we'll just say each frequency, the total frequency has to be even. Won't be possible otherwise. But the question I have is, like, is it always possible to perform these swaps as described? I think so, right? Let's say A is 4, and B is 2, and then A is 2, and B is 4. And there's only two, actually, there's only 2 characters ever, right? That's the other thing, too. This only has 2 characters as well, which makes things a little bit more interesting. Or, yeah, it kind of makes things, has like a certain, it has some implications to it. So I don't know, A, B, A, B, and then B, A, B, B, A, B. Right, let's try this. Can I always do, in this case, we would have A3T, it's going to be A3B3, right, because these added together are 6. And then you want 1 plus 1 is 2, 2 swaps. Is the smallest we can go, right? We have A is swapped here and B is swapped here. 1 and 1. Oh no, excuse me. This is divided by 2. No, I did that wrong. It's 1. It's 1 plus 1 over 2. Gives us 1. 1 swap. Should be able to do this. We could, in theory, we could do this in 1 swap, right? However, I don't think in practice you can do it that way, because even though I'll have the same frequencies, the strings themselves are not really necessarily going to be equal. That's the part I'm kind of wondering about. It's like, well, it doesn't necessarily make them equal. It just means, yeah, that just makes the frequencies equal, which is also a necessary condition. So, like, I could swap, in order to swap 2 characters across, right? I think I need to swap once and then twice, right? So like AB and BA, I think that has to go to AA and BB, and then AB and AB, right? I think it takes 2 swaps. It takes an extra swap to basically do a horizontal swap, right? Is that always necessary? Yes. Yeah, because if I move this A or this B, if they're not equal to each other, one of them has to move somewhere, right? Let's try that. So there's 2 examples to consider here. 1, 2, 3, 4, 5, 6. 1, 2. 1, 2, 3, 4, 5, 6. And this one is A, B, A, B. And B, A, B, B, A, B. B, B. Okay, so these strings are already equal. Probably skip those then. Yeah, so, let's say I don't know the answer to this question. So in this case, even though these are different from each other, you can swap this with one of these. And then it becomes A, B, oops. B, A, and A, B, 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 B. And you could basically do that, until we're done. And that would give me 3 swaps. But the reason I can't really do that here is because it depends on what comes next. So because I have another A here and another B here, even if I swap this with an A, right? A, B, B, A, B, I get A, B, B, A, B. Oh, this is wrong also. B, A, B, B, A, B. A, B, A, oh, this should probably have another. Let's put an A there. Whoops. A, B, B, A, B, right? So the problem with this is that now I have this character to deal with, whereas character difference to deal with. Whereas in the other case, oh yeah, they're still different here. I guess we just push the B further down. Swap it with this A. A, B, A, B, A, B, B, A. I think this is BB. BB. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Well, that's interesting. Oh. Oh. You could just do one more swap. 1, 2, 3. Third swap, you could just do this B. I don't know. I need to, yeah. These are the same, so skip. And then we put, B with an A here. I think you could always do it this way. Okay, the algorithm. Oh no, that becomes a B. Yeah, I think it always works. I think you could always do it this way. So we're gonna get the frequencies of A's and B's. So int A, B, we'll say total A and total B, or total A, total B. Const char ch and s1, total A plus equals ch equals A, total B plus equals ch equals B. Then we're gonna say int constant target A, total A divided by 2. Target B is going to be total B divided by 2. So if target A and 1, or that's a Boolean, or target B, not target, total. Either of these are odd, return -1. Otherwise, we're going to say return target A oh, I did this wrong. There's another one. Int A1 and B1. And this is, oops, A2 and B2. This is going to be A1. Actually, I should do the other way around. It's just A1 plus A2. And this is just B1 plus B2. Okay, that's fine. Okay. So A1 minus target A plus A2 minus target B, B1, and this is all divided by 2. Okay, something like this. And I think the sort of the algorithm that I just gave, I think you can always achieve those minimum swaps. Oh, okay. Maybe not. Oh, it's X and Y, not A and B. Excuse me. X, Y. Yeah, I just converted to A and B. It's fine. Hopefully not too confusing. Hopefully not too bad. 0. Okay. All right. So no, I'm wrong about this. Can't do it this way. Seems like you can do it, but not if. Okay, I need more examples. Why do I just want that to be true. It's easier to program. It's easier to program. Yeah, this is so. If you have A and B and B and A, these are not equal. So you move B's further down. But you can't move the B further down because you end up, yeah, okay, this is a scenario where you run into trouble. Can't move the B further down because it'll just be the same thing again. So you actually need to, is there like is this the only case where this happens? I get the feeling this is the only time this happens. Is there like maybe A, B, A, B, A, B, B, A, B, A? Pretty sure it's the only time it happens, because if you could do, or if you have like, A, B, A, and B, A, these different cases. So this one has 2. This one, you want to move the B further down, so you do, and you end up with A, B, 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 A, B, A, it's 1. And then these are equal. Now you're going to move the B further down. And it's 0, 1. and then A, B, B, A, B, B. Yes, this took exactly 2, which is what I had guessed, right? If it was this, the target would, the total is 4 and 4. The targets are 2 and 2, and then oh no, that's not what I guessed. The algorithm is correct, I think, but the actually, that would say I would have with 0 with this one. It already has the right amount. It's just they're just not in the right places, spots. Is it always just 2? No. Do this? No. Try to do this more efficiently than just using simple brute force, like and I don't know that if a simple brute force would even work here. I'm not sure exactly what that would look like. I'm pretty sure I'd have to use some kind of dynamic programming anyway for that. Possibly. So again, we have the B moves down further. So from 0, we have A, B, 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 A, B, A, B, A, B, A. We have, that's 1 move. Then we push the B down further again. A, B, B, A, B. A, B, oops. B, 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 A. And then we still need to make 2 more moves over here, I think. So that's 1 move, 2nd move. Right, that resolves that part of the sequence. I still need another move. These B's are equal. I can't move this B further down, right? Have to swap. Yeah, I wonder. That's a little awkward. And then these can swap. That gives me 4. Yeah, this is kind of awkward. This is pretty awkward. I don't think it's gonna be that easy. I think quadratic time is probably as good as it's gonna get, which I don't want to do that actually. It seems kind of bad. I don't know. Huh. That's a good question. I think I just didn't think about this for a while. I guess I didn't think about this for a while. It's not obvious at all. How are we doing on time yet? Half an hour? Okay. There's like a few different ideas to consider. So probably the first one is that, okay, it's the first thing to, oh, shoot. Oh, I'm trying to, oh, okay, I guess that's fine. Okay, that's fine. The first thing to consider is this is not going to work. This might work for a lot of cases, but it's not going to work in general. The main issue is that I could have anagrams, but they're just kind of, excuse me, well, it could be anagrams of each other, in which case it's not obvious exactly. If they're not anagrams, I think it's easier. But if they are anagrams, then it gets more complicated. And they're not already equal. Excuse me. I don't know. Could they all be one character? If they're only one character, they're already immediately equal, right? They have to be. Otherwise, there's no way to do it. This first check would handle that, right? Excuse me. How are we doing on here? Okay. Okay, so forgive me. Sorry, I'm like thinking about something else today too. What was I even thinking about? The other thing was, I think this works for a lot of cases, but it doesn't work for all the cases, this idea. That's kind of an interesting thing. That's one thing. The other thing is, excuse me. Yeah, if they're anagrams of each other, obviously that's the case where it fails. Is that the only? I think it's the only case that it fails. That's like what I'm getting at. So I think this can be, there's some stuff you could do here. But let's assume that we have an anagram. Let's assume we have an anagram. Go with that. With an anagram, if they're not equal, yeah, you can use the same algorithm that I described before to handle the differences, right? So, you can do this in two iterations. You can have all four of these characters equal to each other. Interestingly, though, 2 swaps are a minimum that you need for an anagram with A, B, B, A, and then if they're going to be anagrams, they have to be. They have to be. At most 2 characters, I guess, that are out of sync with each other when you have 2 or 3, a length 2 or 3. And the reason is that if you put an A here and an A here, it needs to be equal. B here and B here, it's going to be equal because it's got to be the same. It's got to be an even number of the characters, right? So if I'm going to add a character, it has to be the same character that I add. It has to be A and A or B and B. I can't add an A and a B, right? Otherwise, it's not possible to do this at all. So in that case, though, like if I put an A here and an A here, right, then obviously this character matches. And if I put a B here and a B here, this character, same thing, like it's the same character. I could put A to the right or A to the left. I could put an A in between, I guess. But then again, that just matches, right? So it's not really, then these match. Same thing, if I go like here. Yeah, so basically anywhere I put these A's and B's, like they're gonna match with something. So it just kind of reduces to this case. And then in this case, as mentioned, like this actually follows kind of what we had before, where you only have to move down the B values, and they would match fine. So you get A, B, B, right, in this A. I think I would just do that. Yeah, that works. So end up with A, B, B, and A, B, B. Right, this A comes down, A is here, B is here, this B comes down, yeah. So that would still only take 2 swaps to straighten that out. But what's interesting about these anagrams is add a third one. Third mismatch. If you add a third mismatch, then it takes 2 to straighten these out, but then it takes 2 to straighten these out. So it looks like it would be the number of mismatches. So 1, 2, 3, 4, 5, 6, 6. Divided by 4. So 1.5, rounded up. Right? Yeah. The ceiling of the number of mismatches divided by 4. And I think that's equivalent to this other thing that I calculated over here before. I think that'll give me the same thing, actually. Yeah, could try that. Could try that. See what I get. So, yeah. Also, you can make this a little bit faster if we just don't. Can make this a little bit faster if we just don't. I have to make this constant. I think it's the same thing. Yeah. Okay. Just return mismatches divided by 4. Take the ceiling of that. Maybe I don't need to convert that to a float. That probably works. This is not quite right. There's a one issue here, and I'll explain in a second what that is. And that goes back to what I was saying before about the anagram. If they're not take the sum of these characters, the totals, mismatches, and then like total x, total y. Total x plus equals ch1 is x. Total y plus equals ch2 is y. Yeah. I think both of these. A little bit confusing, but hopefully it's not too hard to follow. We just say if total x and 1 or total y and 1, then it's not possible to do this. Something like this, I don't know. Could try this. Maybe. Oh, oh, still wrong. Okay. There should be 2 mismatches here, right? Oh, wait, I did that wrong. I'm sorry. It's the other way around. Multiply by 2 at the end. Yeah, times 2. Excuse me. Right, it's a little bit confusing. Yeah, so here, these mismatches, I multiply these by 2. Divide by 4 and divide by, yeah, okay. I could just multiply by 2, it's fine. So complicated. something like this? I don't know. Maybe not right. Okay. So it works correctly in this case and in this case, but it's not right here now. Two mismatches. But these are mismatches that aren't as hard to deal with. So I probably should have just gone for like a brute force or dynamic programming, just that way I could get it done and I don't have to spend so much time on this. I'm trying to find like something that's a little bit more clever, but I think it's not a good idea to spend that much time. I don't think so. Part of me thinks there's got to be a way that's like very simple for this. You know, I think there's a simpler way to do it. I mean, why is this one? What's the difference between these two that makes it so much harder? Or yeah, what's the important difference between these two? Well, in this case, you could just swap the y and the x, and you're done. Excuse me. Whereas in this case, you have to swap. You can only swap this x with this y, otherwise you get the same thing if you swap these two. So you've got to go to. You actually have to go to this case first with one swap. Okay. Alright. I gotta sit and think about this for a while. Excuse me. I need to think about this for a while. Maybe I could just use a linear time algorithm. Something that's just a linear time approach. So like what I could do is say, okay, if there's a mismatch, I'm going to scroll forward to try to resolve that mismatch. And if I get to another mismatch, then I've got to resolve that with two swaps, right? Whereas here, I have a mismatch, and then I immediately get another mismatch. But in this case, I have two mismatches, and it's actually easy to resolve with one swap. And in this case, I have two mismatches, and I have to use two swaps. So I think all I have to do is just scroll forward to find the next mismatch, and it depends on if it's alternating, then I can use one swap. If it's not alternating, I need to use two. And I think that's it. Is that true? No. Because you could do XX, YY. And this could be XX. Oh, no. It could be 1, 2, 3, 1, 2, 3, 5. That's confusing. Not really exemplifying this correctly. No, I guess I'd think about it for a while. I want to say I assume there's a linear time algorithm. That's kind of, I'm thinking there is. There's a part of me that thinks that there's probably a linear time way to do this. It's just not obvious how to do that. A linear time approach. All right. Let me think about this here. Ooh, excuse me. A linear time approach. So if I have 0, 0, and 1, 1, right? 0, 0, and 1, 1. That can be, you could use one swap to get 0, 1, and 0, 1. Right, 0, 0, and 1, 1, 0, 1, and 0, 1. That's one swap. If I had 1, 0, and then 0, 1, right? That would take 2 swaps. Okay. And if there were a whole bunch of matches in between, matching characters in between, it wouldn't matter, right? I could actually cut those all out. I would get the same kind of thing going on. Is that true? I think so, yeah. Yeah. I had a bunch of matching zeros and a bunch of matching ones between those mismatches. So in both cases there's 2 mismatches, but how they're mismatched matters. Doesn't necessarily matter what's in between. Now, if I had three mismatches, right? Actually would need to go to 4 mismatches because 3 mismatches is not necessarily enough characters for that to work, right? With 3 mismatches, that means you have one of each character 3 times. 3 X's and 3 Y's. Oh no, actually, yeah, that could work. Is that right? You'd have X, Y, X, Y, X, Y. Yeah, okay, no, that's fine. Actually, that's fine. That works. Never mind. That's fine. No, it's not fine. No, it's not fine. If it's three mismatches, that implies that you have 3 X's and 3 Y's, but you need to have an even number of X's and an even number of Y's. Yeah, so you can't have just three mismatches, so that's not possible. Or at least I would just return a -1 there. If there are 4 mismatches, then so does it have to be an even number of mismatches? I think so. Yeah, if you have an odd number of mismatches, then it's not possible to do it because that implies you have things that are not mismatched. Obviously, there's an even contribution, so that means you have an odd contribution to both X and Y if you have an odd number of mismatches. So that gives me an odd total for X and an odd total for Y. So it has to be an even number of mismatches. We could skip the ones that are not mismatched. The problem that I have is what if you have 4 mismatches rather than just 2, right? Do you still have in some cases it can be resolved in 1 swap, in some cases it can be resolved in 2 the 2 mismatches at a time? I think that's the question that I have to answer here. It's critical answer. That's the thing that I was kind of seeing before, was that if there are an even number of mismatches, can I group them into groups of 2 and then resolve them one at a time as taking either 1 swap or 2 swaps? So I think part of the answer there is if I tried to do that, I think that almost every mismatch can be resolved with 1 swap. That's what I'm trying to say. That's what I'm trying to get at. Each group of 2, almost every one of them except for maybe 1. And that's part of the confusion. I think therein lies the confusion, right? So you could have just 4 X's and 4 Y's, right? In which case there'd be 4 mismatches. However, you could swap. So in that case, it should only take at most 2 swaps, right? Because it's just the XX and YY twice. Both of those only take 1 swap. However, you have XXYY twice. Yeah, XXYY and YYXX, right? How about that one? So now the mismatches are flipped. So the first 2 could be addressed in one swap, and the second two could be addressed in one swap. No. So it's got to be XY, XY, and YX, YX. That one. That one also could be addressed in two swaps. That's why I'm confused about it. It's like, wait, how do I? There's a lot of different ways this could be mismatched with four X's and four Y's. How many different ways could it be mismatched? Well, if the groups of two are, if it's XX and YY, then that could be swapped with one and reduced, right? If it's XY and XY, that's not mismatched. If it's XY and YX, then that could take two swaps, potentially. Yeah, something like XYXX and YXYY is a good question. Does it take three swaps? Right, that's what I'm trying to get at. I'll check that one now. I'll think about that one in a second. But the XYXY and YXYX, that only takes two, because you can take the first X and swap it with a later Y, and then you could take the next Y and swap it with a later X, right? Is that right? So the first XYXY and YXYX. I think I showed that before. It only takes two swaps. So I think it's only. I think it's only this case when you have X, Y, and YX. Do you end up doing one extra swap for the mismatches? That's what I'm thinking. I realize it's confusing. It's hard to even explain. Let's see. Let's do this. Otherwise, the number of swaps is just exactly the number of mismatches divided by 2. Excuse me. All right. So I keep zooming in, zooming out. So okay, one more time. So X. Okay, let me zoom out a little bit. There we go. All right. So you have XY, XY, YX, YX. Now normally XY and YX. This takes two swaps. And I think this is the only situation where, I think it's only when it's a length 2. And the mismatches are exactly this, in this sequence. Because if you do it this way, you could just swap this Y and this X to get YY, XY, and then YX, XX, and then just swap these two, right? And you get YYXX and YYXX in 1-2 swaps. And that's it. It's pretty straightforward, actually. But that's exactly, that's sort of like the worst case you can get in two mismatches, right? Is that they're kind of swapped around. But the other mismatches, other possibilities are just kind of reiterations of the other case, which we know this only takes one because you could just swap Y and X. Yeah, and you could just do that twice, right? That's like no problem. If you have an odd number of mismatches, this obviously, so I should count the number of mismatches. Yeah, I don't know. Normally going to be number of mismatches divided by 2. That's I think most of the time. I don't think I even need this. The only time I think where it matters, because like even if you mix these, right? Right, even if you mix these, that's kind of what the other consideration was, that what if you mix these two types? If you mix them, then I think you still only have two swaps. Like I think it just reduces this to one swap. So you could do a swap here, and you get y x y x and y y x x, and then you could swap. Oh no. No, maybe. Hold on. Yeah, about this one. Huh. Good question. If you do this, you get x, x, y, y with x, y, x, y. And then you kind of have a problem, don't you? Oh. 1, 2, 3, 4, 1, 2, 3, 4. Oh, wait. I think I can do it this way. X, x, y, y. I want to say I can just put an x here, right? So I get x, x, y, 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 x, x, y. And then I can swap, I can't swap these two, can I? Oh yeah, no, actually, maybe this is harder than I realize. Can I do this in 2? I don't know that I can. Maybe I have to do it in 3. Put a y there, x, x, y, y, x, y, x, y. But then I've got to swap these two, right? It looks like everything, so let me actually try that. I think it's 3 for this one. Actually, maybe let's try that, x, x, y, x. That's a good question. In my mind, I'm thinking that actually it's easier than it is. Yeah, I don't know. Oh. C1, C2, CH1, CH2. Char1, char2. Output's 2. Oh no. So I did 3. Okay, it is 3. All right. Okay. So yes. If I mix them together, I do still have to do 2 for this one. But what's weird about it is if I don't mix them together, they reduce to so they like self-destruct. If I see this pair, this actually becomes 1, but if I combine them, it ends up being 3. It's like 1 plus 2. That's really confusing. So I need to count how many of these I see and the number of these that I see. And the number of these just give me, sort of, this is like alpha times 1. And this is going to be beta divided by 2 times 1. Divided by 2. No. however many there are of them, if there's 2 of them, oh no, I'm sorry, it doesn't become 1, it becomes 2. If there's 2 of them, it becomes 2. If there's only 1, it's still 2. So somehow I can group them into groups of 2, and there's just size 1. But if there's only 1, there's 2. But if there's only 1, there's 2. I think it's going to be the roof times 2. Ceiling times 2. So if there's only 1, if there's an odd number of them, I've got to account for 2 swaps. If there's an even number though, then it's just beta, right? That's confusing. So it ends up being like alpha plus the ceiling of beta times 2. Beta over 2 divided times 2. Yeah, that seems to be the correct formulation for each of these groups of mismatches. Interesting. How do they mismatch? Is the question. And then you can also do like x, y, yx is kind of equivalent to like yx, xy, right? That's the other thing. So there's 2 different types. There's xy, yx, which I'm pretty sure are the same. Like they give me the same sort of results, I guess. xy, yx, and then yx, xy. Then there's xx, y, and then y, xx. Which I think if you mix them, that makes things more interesting too. So the next test case to consider would be xy, yx, xy, yx, and then yx, xy. And this would give me, how does this work? xy, yx, yx, xy. Excuse me. So that actually gives me only 2. Yeah, that's actually what I predicted, right? I was saying if there's 2 of these, even if they're swapped in the sequence that I'm seeing, it's still going to give me, it's going to still count till beta for beta. So that's kind of the idea. Like both of these would still, yeah. And then I can mix and match over here too. This xx, yx, and yy, xy, and xx, yx, and yy, xy. What was I doing? So xx, yx. What's the other one? YY, XY. Yeah. All right, these things. I did this before, right? If I swap these things around and I do YY, XX over here, for example, it should still give me the same result. It should still give me, I think, 3. Right, that was kind of the point I was getting at, that there's like sort of an analogy between these. Yeah. Okay, so that's fine. So I don't need to worry so much about like, what I need to do is I need to group these mismatches in groups of 2. And then there's going to be 2 different types of mismatches: the alpha and beta mismatches. and then we just say alpha plus beta. And what this should be is just alpha plus, depending on the mismatches that we're dealing with, that I'm dealing with. Oh boy. The alpha type is just going to be the same two characters twice that are different, and then the beta type is going to be they swap. So two mismatches, but they swap. Yeah, I think the total number of mismatches also. So each alpha and beta actually requires, yeah, so it's, yeah. So I do need to count the number of mismatches, actually. Actually, do need to count that. Okay. Yeah, because alpha and beta are basically, each of them are two mismatches apiece, so it's always going to be, it'll always, if I use alpha plus beta, it's always an even number. Anyway, so this is alpha plus beta divided by 2 times 2. Yeah. No. It's a ceiling of beta divided by 2.0, right? And then multiply by 2. Yeah. Should convert that to an integer, I think, afterwards. I don't know if I need to. I might need to. Okay. So all right. So anyway, all right. So I've got alpha and beta. What I'm missing, oops, keep clicking that. Try not to click that. I'm so used to like being concerned about doxing myself, right? But it doesn't actually matter if I do that, because my whole channel just has my name on it. So the thing I'm more concerned about is sharing. Sometimes notifications show up here, and I don't want them to show up there, and various things on my computer, and I don't want to share those things. And I don't want to share those things. Okay, so the issue is the mismatches themselves. What they are is kind of the question. Oh man. Sorry, sometimes I have these thoughts that they're not invasive thoughts, they're just not fun to think about. That's the other thing. People say, oh, you have invasive thoughts. It's not invasive thoughts. Like, my life is hard. Like, my life is freaking hard. Not invasive thoughts as much as they are just painful things to consider. Things that I wonder about from time to time. Yeah, I feel like I've been betrayed in subtle ways many times, and I'm learning that in the West, this is very typical. There's a certain group of people that does a lot of that betraying. They do a lot of that. And it's hard to tell who they are, because they literally pretend to be other people, right? Which is insane. Yeah, and I wonder sometimes, they're actually most dangerous if they're your friends. And the thing that's awkward about it is that, like, some people in my life would go out of their way to be my friend, and I would have to wonder, especially now, like, what to make of those people, right? Because I think back to like little things here and there. It's like, yeah, like these people, like, I've spent enough time with them to kind of rack up a kind of a scoreboard of like all the different times they've betrayed me in some subtle way. And other people don't do that, right? Like, other people, now you could say like, well, you don't really get close enough to other people to really know. And part of the problem is like, well, I didn't spend that much time with other people because these people wanted to spend time with me and went out of their way to spend time with me. So I spent time with them and I didn't really think about it, not realizing that like they may have done that because they're most deadly and dangerous if they're your friend, right? Yeah. These aren't fun thoughts to think about. As I said, like these thoughts are not fun, painful, very difficult, very painful. And yeah, I mean, it's one of those things where you have to like, if you're dealing with, basically if you're dealing with spies, if you're dealing with spies, how do you contend with them? How do you deal with spies? Because the most dangerous spy is your friend, right? Is the spy you think is your friend. And what about spy networks that transcend multiple generations, right? And they literally have their kids play with you when you're a kid in order to like infiltrate your group, right? And destroy you and destroy your group and destroy your group through you. It's like that's that'll make you crazy thinking about that stuff. And yeah, I have to actually think about some of those things. So it's kind of difficult. It's kind of difficult sometimes for me. I have a lot of enemies. And it's it's one of those things where it's like, well, with friends like these, who needs enemies, right? And yeah, so it's not fun. Not fun. Maybe very uncomfortable when I was younger. Some of these things, I was like very insecure. Didn't have a lot of confidence because I was actually being like undermined. And like I get undermined by people all the time. By people that shouldn't be doing that, but they do it anyway. And it's kind of like, Jesus, God help me. And it's hard for me to tell sometimes if like, are they doing it on purpose? Is it just because they're not too sharp? Is it just because they're greedy or selfish? Like what exactly am I dealing with here? Can be hard for me at times. It can be hard for me at times, and I often wonder what my response ought to be. Yeah, it's like usually it's just difficult to just say. It's just generally a difficult thing. I've been made to endure many painful and difficult things in my life. A lot of which, like I didn't, it's like I didn't really have control over those things. They probably should not have been, quite frankly. Yeah. Anyway, I don't want to get into too much detail with those things, but just say life can be very hard sometimes. Life is not easy. Life is about struggle and pain and struggle. Pain and struggle and defeating your enemies. Pain and struggle and identifying your enemies too. Identifying and destroying your enemies. That's what life is about. Anyway. These mismatches, right? So I could write this algorithm and see how this goes. What I need is when I identify a mismatch, let's just say const bool check. So if check, I'm going to increment the mismatches. The other thing I'm going to do is depending on what the characters are. So I'm going to look at the previous character, previous ch1. Let's do it that way. And I'm going to set this previous ch1 to ch1. And I'm going to check and say, okay, if ch1 and also have a Boolean. Previous mismatch equals false, right? So if the previous mismatch is true, then I'm going to do some things. If it's not true, then I'm going to toggle previous mismatch. I'm actually think I'm going to toggle that every time. So previous mismatch equals not previous mismatch. I'm trying to think how can I do this in a relatively clean way. So there's a previous mismatch. If it's true, then I'm going to take this new mismatch and compare and say if the previous character is equal to this current character, I'm going to do one thing. And I can actually just check two. Same, we'll just do same. Previous CH1 is equal to CH1. Then I can say alpha plus equals same, and then beta plus equals not same, just to avoid another branch. And the idea here is that if in the next mismatch, if the character 1 matches the previous character 1 from the previous mismatch, this actually should be set here. If it matches, then that means this is type 1, right? This is the type, type alpha. If it doesn't match, then this is type 2, it's type beta. And yeah, I'm only going to set that previous CH1 to only when I have a mismatch, when that occurs, then I'm going to set that value. Yeah. And obviously, right, this is going to toggle between true and false. So it starts off at false. I get a mismatch. This should be false. We skip this part. We set it to true now and pick previous CH1. Then the next iteration where I see a mismatch, that previous mismatch is true, and then I check, my same check, right? Then I flip the previous mismatch and I say, okay, now that previous mismatch is handled, like that's gone, done. And then it doesn't matter if I set this value because it's going to be false now. And so the next time it's going to skip anyway, whatever this value is. So we don't really care. We should basically throw it out for the next iteration. Yeah, something like this. Something like this is what we're after, what I'm after. Okay, it looks good for these cases. Now the problem is it correct in larger test cases, right? That's the question. That's the question. So we just have a whole bunch of, values, right? Let's see if this works for case 7. So it looks like it's possibly works. Let me see. Do I need another X, another Y? Seven, 5, okay. 8, and if I put XX, it should stay the same. So I don't actually know. There's a chance this is wrong, I didn't really test this on enough things to know for sure. I kind of just want to try some things here. X, Y, X, Y, right? Just put some random stuff in there, see what I get. I don't know. I mean, I could, I guess, generate random strings that are the same length. 2 random XY strings of the same length. Yeah, I'm thinking, because I didn't prove that this is correct. I think this is correct, but it's definitely not the most obvious thing. Let me try that. Let me try. Yeah, let me try this. Just check chat. Okay, so as you can tell, sometimes it's hard for me not to try to get like the optimal solution or like a better solution, faster solution, even if maybe I could do a suboptimal solution, like either some kind of quadratic time solution. I actually don't know what that would have been if I did that, but yeah, I'm spending a lot of time on this, but I think it's okay. Let me try to. It's okay in the sense that I like having a better solution. Let's do this. We want two strings x and y of the same length. We need an n. X, y, n. We need actually random numbers, random values. So we're going to do state plus %s %n and get line seed and then srand seed and then print srand just to make sure that I got that correct. Okay, n is just be like, make it 0 for now. Okay, that's fine. Now, x and y int should be rand int of 1 plus, what do we want? 1,000, I think. Yeah, 1,000. Okay, C1 is 1,000. Let's do like 100. Let's do 100 for C1, right? And then now I want to do I is 0, I is less than n, increment I, x equals something or other with x, y is something or other with y, and then we're going to print x and y. And both of these need characters. All right, let's do that. Okay. So what these are going to get is if x is I is greater than 0, then we're going to do x equals a comma x, and then y equals a comma y. That gives me a bunch of commas. And then this is going to be x with just a random number from 0 and 1. It's going to be, it will do a random number from 0 and 1. Let's do it that way. Yeah. Okay, and I tend to mix this up. I think it's this way. Oops. Yeah, that one's kind of an easy one to check, but it's just oh no, actually I don't need those. Don't need those at all. But it's going to be, if I is greater than 0, then I'm going to put a comma before. I'm going to put a comma after my x and y, and then I'm going to add something after the comma. So I don't add commas for the first one. That's really what that means. Excuse me. Okay. All right. I want to, now here's something, sprintf, which got to be kind of careful with the print routines. I'm going to convert these random numbers to, it's going to be, I think it's %character. It's going to be like 97 plus, I don't remember if it's X, Y, Z, right? 26, it's like 24 or something like that. 97 plus 24. I don't know if that's going to be correct. Something like this. Oh, there we go. It works. Okay. X and Y, right? So 23. That's X. Okay. And this is going to be from 0 to 1. So, 0 to 1, no, 2. Yeah, that'll be 0 to 1. And I can maybe make that another constant, which doesn't really need to be another constant, but there we go. Okay. I'm gonna might as well make another constant. That's might as well. The range is from 0 to 2. Okay. Very good. Very good. So do for 4j in sequence 1 to 8. Do done. Boom. All right. And and the n value I didn't do that right. Times rand. There we go. All right. So we'll do a bunch of these random sequences. Do it like 4 times, because there's a good chance I'm wrong with this solution. You know, I just think it might be right. I didn't really prove it. It seems correct. It's a good chance that I missed something important. It's hard to tell. And you don't necessarily want to spend that much time, or you're not even really sure where to begin to make sure it's right. It just takes more time, whatever you're doing. Usually the issue is just a matter of time. Let's do 4 and 5. That was 3. Let's do 4 and 5. 4. Let's do maybe one more after this. One more after this. So that's pretty, like, it's looking pretty good. It's like a lot of, I don't know, maybe I'd go for more, right? It's like a lot of cases where it seems to be correct. Right? Like a lot of cases where it looks correct. I don't know. I don't know, man. Maybe I'm right. I don't know. I could try it. I'm going to go for it. It could be wrong. It definitely could be wrong. That's right. Okay. Just not very confident with that one. Just not very confident with that one. 100%. Hail victory. Hail victory. Super fast solution. Extremely fast. Yeah. Lightning fast. How's that? Linear time. Yeah, beautiful. Beautiful. That's what I like to see. All right, let's submit it 4 more times, and then I think I'm gonna take a break. I think maybe this will be the only question I do today. I might do another one. I'm not really sure. Yeah, I mean, what is it? It's almost 8 o'clock my time. I mean, I can go for another couple hours, but I don't know. That like took me a long time to think that all the way through. That was pretty. I didn't feel good about it the whole way through too. I felt like I probably got it wrong the whole time. The whole time I'm like, I don't know about this one, man. This is pretty uncertain for me. 1, 2, 3, 4. Let's do one more. If you like the stream, give it a follow. Oh, excuse me. If you like the stream, give it a like and subscribe for more videos like this. 4, 5. Yeah, let's submit one more time. Yeah, I mean, you know, it's like, it's reasonable. Is what it is, you know. Fast solution, linear time solution. I don't know what to say about this. It's pretty low number of submissions. A lot of people skip this one. I don't know what to say. I mean, like, I really don't know. I don't even know. This is a very kind of unique question. I can say that much. There are quite a few questions like that on LeetCode where it's not your typical question, and it's really got a lot of room for consideration. Like this was quite a unique thing, unique solution, unique kind of problem. linear time solution after all, but there were quite a few things in there that were very non-standard, we'll say, as far as algorithms are concerned, in order to get there. Yeah, some of the things I don't even have the words to describe exactly what these things are, like homomorphisms, things like that, homomorphic sort of structures. And there's sort of maybe some inductive proof you could go for to prove that this works. Different cases involved. Like, it's not obvious at all that this is exactly correct. And it is, like, according to the test cases, according to my testing, like, it's correct, but it's just not obvious at all why. Definitely not. Take quite a bit of time, I think, to prove that this is correct. It's like, that's kind of the thing with the LeetCode questions. Like, they're usually, I don't know, they usually have non-obvious solutions that take a while to prove are correct. That's sort of, and those are like the optimal solutions usually. And it's kind of annoying, quite frankly. Like, I don't like it. It's like really annoying. It's definitely easier if you've just seen the question before. You can just restate the solution that you have. You don't have to go through all that, like, thinking, do all that extra thinking. Yeah, I don't know. I don't know what to say about it. I like being able to think it through and being able to get there, but it's definitely a pain in the neck. If you have like a lot of questions you want to go through, it's like it takes a really long time. It's just a lot of time. I don't know what else to say about this. Interesting question, no less. I don't know. Okay. All right. Got there. Got there. Yeah. Huh. I've been thinking lately about like machine learning and artificial intelligence, right? All that those sorts of things. And like, how could you have a machine solve this question and basically do what I just did? Might be kind of challenging. I think it's doable, but it's definitely involved. Whatever that process looks like, it's definitely pretty involved. I think we're close though. I think we can get there. I think absolutely we're like very close, if not already there, already capable of that sort of thing. Because this wasn't that crazy, you know. It's like it's not. It's just, I don't know. I don't know, man. I just spent like the past like hour and a half doing it, and I still don't really quite know how to explain it. Like, I don't know. It's like, that's what I came up with. It works. Like, oh, okay. Great. Yeah, well, I mean, I kind of explained it. I tried to. I don't know if that was a great explanation, but it was basically, yeah, the mismatches can be grouped into groups of two, and sometimes you need to use two swaps to address the mismatch, and you can ignore things that are already matched. So you only care about the mismatches, and then you can group those two mismatches in two different types. And one type, you can always use one match for that group of two mismatches, and then the other type, you sometimes have to use two, but most of the time you can use one as well. And so that accounts for all of the possibilities. That's it. That's it. That's it. Done. Okay, and there's like a homomorphism too of different, of these types as well. You just have to identify those, and then you make your calculation. Yeah. All right. All right. I don't have to. I'm gonna spend more time on this. That's it. that's it. Okay. And that gives me, fastest solution on the website. 0 milliseconds. Okay, I'm gonna stop there. So yeah, again, thanks for watching. Give the video a like if you liked it, and yeah, you can subscribe for more videos like this. And I'll take a break here. I don't know if I want to do another one. These are always just like, I don't know, man. Like, they're just so. I feel like I have to think so hard about these. I feel like I have to think so hard about them, and I don't know. Like, I don't want to do another one. It's too much. It's too much. I'm always trying to like optimize it and get it perfect, and just if I don't think enough about it, I'm gonna feel bad because it's not as fast as it could be, and then I don't know. I don't know what to say about it. Just my brain. Do a lot of thinking, man. Do a lot of thinking. Sometimes just take a break. I might come on and do another one. I don't know. I might get kind of bored. That's the other problem I have. Is like I'm so bored. I have like I'm just really bored all the time. Because like I just have nothing but work to do, and like it's not very exciting, and I often don't want to do the work that I have to do. Not because of like not out of like negligence, but just like it's just not enjoyable to do all the time. I don't know how to phrase it, express it. It's not even that. Like I do genuinely feel like you need to give your brain some time to like just think of other things, or just let it like kind of rest. Like you just can't just be constantly trying to think about different questions all the time. I don't know. Like you just won't get right answers sometimes. Like I don't know what to say about it. Like I'm kind of rambling now, but about something unrelated to the video. But it's just this question. It's very like you end up in a situation where you're like smacking your head against the wall trying to think of an answer, right? And like it's not bad to sit and focus, but like I think you do need to allow your mind to kind of like give it some time, not think about it for a little while, come back to it with different ideas, fresh perspective, that sort of thing. Like I don't know what it is about how the brain works, but it just you do need time. There's like an element of time that's important. Um yeah, I don't know, I couldn't even explain it. Couldn't even just really describe it or explain it, but I've definitely noticed that. And I think other people have noticed that too. That's like it's usually better to kind of put things on the back burner for a while. Not always, and there's some merit to like, well, just trying to keep thinking about it really aggressively. It does give like the results for me. My best, some of my like, but if I keep hammering away at a question, I do get good results. So like, I don't want to say that you should always spend more time not thinking about it or taking longer breaks or all that. Like, I think it's somewhat overstated how valuable breaks are for your actual performance. However, for like your sense of like, I don't know, like psychological state, you probably should take breaks and frequent ones, right? Like that question was like, maybe I want to think about that for a while, just ponder it. Because that was so different, so unusual, so like very unique. Like it's not a dynamic programming question. It's not a sliding window question. It's not a binary search question. It's not a tree based question or graph question. Like it's none of those things. Like it's I don't even know how to describe it. Like it's just a logical question. You could just reason out the solution that's optimal and provably optimal, right? Like you can't do that faster than linear time because you don't even know what you don't have to know what the strings are in the first place to even reason about them. Yeah, I don't know. Questions like that kind of they kind of throw me through a loop. It's like, how am I supposed to reconcile that in like more? How am I supposed to generalize that to other questions that are similar? Like it's definitely, yeah. That's like those are the kinds of questions I'd want to ponder and sit and think about without just like diving into another question. Like, if I came across something like that again in the wild, because obviously that took me quite a while to solve. What would even be my strategy, my approach? Like these are the kinds of like I think that's what I mean. It's like when I say that you need to take breaks because like you need to think about more than just the thing you just did, right? You got to like think about things related to it, sort of more generalized questions and like meta kind of questions, and what are the implications and all the like other things have to be considered, and you got to like give yourself some time to think about that. You can't just like constantly jump from one thing to the next without considering like what just happened. Like what did I just do and what does it mean? Yeah, I think that's probably a better That's like a much better explanation of what I'm trying to articulate here. That like, yeah, definitely, that's a reason to take breaks because you want to think about other things that are related to the thing you just did. For example, how can I generalize what I just learned? Like, what's my strategy if I see a similar question again? Right, those sorts of questions, sort of more meta analysis type things. There's like lots of other questions you get asked too, but yeah. Anyway, okay, all right. I'm gonna go. Or also, like, what category of questions does that even fit in? Like, I don't. String questions? I don't know. Array questions? Like, swap questions? Swapping things? Maybe some kind of sorting? I don't know. No. Yeah. Anyway, okay. I'm gonna go. Thank you for watching. Take care. Talk to you soon. Take care.